Hi everyone, I'm Bence Csáti, software engineer at Axoflow, as you heard. I'm currently, besides being a software engineer, I'm maintainer of two CNCF sandbox projects, logging operator and bank vaults. But today we are going to talk about Kubernetes logging and some evolvements we made recently. So let's see what we have out of the box when first working with Kubernetes. So when you install Kubernetes, this is basically what you have. So the container runtime redirects the standard out and standard error of each container that is running within pods and nodes to a file on the node. And when you call kubectl logs on a container of a pod, the kube client basically just reaches out to the Kubernetes API server, then forwards your call to the kubelet, which is running on the same node as the container you would like to tail, and it reads the appropriate file. And that's basically it, what you get out of the box for the logging architecture of Kubernetes. But there is a few things you can adjust and modify, but only with caution through the kubelet, and those are mainly for log rotation and log location settings, but work with those with caution. So, but let's talk about the logging operator. So, when reading through the documentation about Kubernetes logging architecture, you will eventually stumble upon a line that says Kubernetes does not provide a native solution for cluster-level logging. And this is one of the main reasons why the original maintainers and creators made this project come alive. So it is an operator, obviously, and it works the following way. You define a logging custom resource, which basically configures your log aggregator, which can either be Fluentd or syslog-ng. And also it has some settings for global flow control, namespace watching, and configuration management. So that's the logging. And next up, you need something that will collect the logs for you. And that would be Fluentbit. So you can deploy that as a separate custom resource, the Fluentbit agent custom resource. This custom resource eventually will be deployed as a daemon set, meaning that it will be present on every node of your cluster. And the final thing you would need are flows and outputs. Flows essentially will route your logs from your aggregator to your specified output. There are two types of these. You have cluster flows and normal flows. Normal flows can only operate in the namespace that is deployed in, and cluster flows has the ability to collect from all of the namespaces. And basically how they work is that they match and or filter on the collected logs and route them to the specific output. And for the outputs, you have cluster output, which is available from all flows and cluster flows, and obviously the normal namespace level ones. And for outputs, they just it is a separate custom resource, but mainly it covers all the necessary authentication and options that is required by any of these outputs you would like to use. We have a bunch of options available. You can see a few of them on the picture. So let's talk a bit about multi-tenancy. It's a big leap forward, but we need to continue with that. So a bit of history about the logging operator. So it was implemented around 2018, about version 1.10 and 1.11 of Kubernetes, when operator patterns were just emerging as an extension pattern. At that time, the ecosystem was mostly prioritizing functionality and stability over the multi-tenancy considerations. And as I mentioned before, the operator was initially trying to solve the problem of cluster-wide logging without the tenant isolation capabilities that nowadays became essential for enterprise Kubernetes. But let's talk about what multi-tenancy actually means. So there is not a single good definition of a tenant, but rather the definition will vary depending on whether we are talking about soft or hard multi-tenancy. So soft multi-tenancy relies mostly on namespace level segregation, RBAC, network policies, resource quotas, etc. It is suitable for small teams and organizations. It has a lower overhead, but it is less secure, obviously. Hard multi-tenancy, on the other hand, implements strong isolation using separate nodes or even separate clusters, and it is required for multi-customer scenarios with strict security requirements. It has a higher resource overhead, but obviously more secure. In many cases, the same organization may use both definitions of a tenant in different scenarios. So this is what we needed to implement in the logging operator. You see, we didn't have a solution for multi-tenancy, but wanted to evolve. So there were several ways to design and build a multi-tenant solution, but it becomes a hard thing when you have some existing patterns and architectures behind you in a pre-existing project. So each of these methods that I talked about before comes with its own set of trade-offs and impact the isolation level and the implementation effort of a solution. But the team sit together and implemented multi-tenancy into the pre-existing logging operator architecture. And the idea was the following. So each tenant should be powered by a logging resource, and the whole observability stack of a cluster should be led by an operations team, meaning they control the Fluentbit agent custom resource and its configuration. A tenant user should configure their own flows and decide on their own outputs. And optionally, an operations team should have its own aggregator for monitoring and security purposes. So that was the idea, and we should see a demo. I had some troubles with the screen sharing, so I will be dragging some things over. Sorry about that. Thankfully, we will have 3 demo scenarios. So, yeah, let's use this. So, the manifest I've deployed previously came from this small script. I've created 2 clusters using kind, loaded the freshly built logging operator image, set some arguments, which we are going to talk about later, and also applied some manifests. And to mimic some traffic, I've created 2 log generator instances. But let's see the logging resources. So if you remember the slides, I have a logging resource for let's say a customer that you see two namespaces here, but the infra one is needed for the logging resource. This control namespace basically means that all the resources that will be deployed by the operator will be deployed in this namespace. So secrets, the Fluentd, stateful set, and so on. Watch namespace decides which namespace should be watched over by this logging. The root config, we are going to cover this later. Flows and outputs. Right now, this is a namespace level flow, which will match on logs that are coming from a pod within the customer A namespace that are coming from the log generator, and it will be outputted to an endpoint over HTTP, which was deployed as part of the Helm chart deployment. And for the infra, we have kind of the same thing here. The only differences are the following. So we have a cluster flow collecting from all namespaces to watch over the whole cluster, a cluster output, and with a separate receiver for the infra team, and the Fluentbit agent custom resource, which I mentioned that they control the Fluentbit agent and its configuration, and the multi-tenancy, which is basically done by this logging route, which works the following way. So it has a source which points to the logging graph from a Fluentbit agent. So previously, if you remember around the first slide, I said that flows works on the aggregator level. So they are routed from the aggregator level, but now with the logging routes and the tenant isolation thing, we are routing from the Fluentbit agent level. And we are matching on logging resources based on labels. So if you see, we are matching on a key tenant label. This is present on customer A, and it's present on the infra one too. And if I find my terminal, if we check logging routes, we can see in their status, it shows that we have 2 tenants, customer A, which consists of 1 namespace, and infra consisting of these 2 namespaces, everything else. And if we go into the cluster, we can see that we have this log generator creating Nginx access logs for us. We have another one of these in the infra namespace. Each of the tenants has its own aggregator. So for customer A and infra, and the Fluentbit agent controlled by the infrastructure. And if our deployment is successful, then in the logging operator's test receiver, we should be able to see only customer A-based log messages arriving. And yeah, we can see that the tenant is customer A, and we should not see any infra logs here. Whereas on the infra test receiver, we should see both customer A logs coming from the customer A tenant, and we should be able to see the infra logs themselves somewhere. Yeah, for example here. So that's basically what we did. I will try to get back to awesome. So up until now, the Fluentbit agent had to handle a single aggregator, as I mentioned before, but now it has to route logs to all the tenants, its own aggregators. And if that is not configured correctly, one misbehaving output can take down the other tenants too. So this is one of the first caveats I've just collected here. And in theory, we could obviously configure a logging route for each logging domain that would solve this problem, but it would require running a collector Fluentbit stateful set for each tenant, but that would be a waste of resources. So you shouldn't do that. And another caveat is that we pointed out is noisy neighbors. So it is a term for an overactive member of a tenant. So within Fluentbit, it is possible to set a global upper buffer limit, but there is also one per output. So if you imagine a scenario when you have two tenants consuming logs, and one of the aggregators become unavailable for some reason, in a lucky scenario, your Fluentbit agent will start to buffer up logs instead of throwing them away. And upon reaching the disk limit or this upper buffer limit, the collector will start to fail, and the other outputs and aggregators will suffer the consequences of that. And another caveat, and the final bigger one that we faced, is that right now we created another level of log routing. So as I mentioned, there was the aggregator with flows and outputs, and now we have another one with logging and routes. This is good. We can route on another level. This is somewhat useful. We can route on a limited set of attributes, so logging domains, for example, and namespaces. This is somewhat good, somewhat bad, but it limits the complexity, so less space for errors. But we knew that this is not a great solution. So although some users were satisfied with it, we were not entirely. So we knew that an OpenTelemetry collector-based solution would be better. Besides, it was on the table long ago that we would like to support it in the logging operator. But we had a few key points. So we wanted to make an OpenTelemetry-based solution that is very good, crazy simple to use, and fast and easy. So, but first things first, we had to decide where to put this within the logging operator. So we started doing a number of proof of concepts and research where its place should be, and we discovered that it wouldn't be a great solution to put this within the logging operator itself up front. So first, there is a big architectural mismatch. You see, as I mentioned before, the logging operator was created to solve the cluster-wide logging problem. And OpenTelemetry, on the other hand, is a comprehensive observability framework, and it handles much more than just logs. And it also has a different architecture and data model. Second of all, we are aware of a number of logging operator users that invested heavily in implementing and maintaining their logging operator-based observability stack. And many of them have built operational processes, monitoring systems, and compliance frameworks around the specific capabilities of the logging operator. And introducing this would require the existing users to adjust their builds and workflows. And we didn't want to force them to do that. And third, obviously, it would introduce some unnecessary complexity. Forcing the OpenTelemetry upfront into the logging operator would create a somewhat hybrid solution, and it would not serve neither purpose well. So instead, what we thought would be a better approach is to create a new project, create a new operator, designed around the OpenTelemetry's architecture, while maintaining the logging operator for environments that needs these specialized cluster-wide logging capabilities only for log management purposes. So we created it, and we often tag it as an opinionated, convenient, robust API that can turn telemetry event streams into Kubernetes resources. So it provides a isolation and access controls somewhat similar to what you have with Kubernetes, provides for pods, secrets, and other resources. It has a hard-to-break design that someone would say to his boss about the new project, but Telemetry Controller is actually hard to break because of a number of reasons. First, the OpenTelemetry collector configuration is created entirely by the operator. We only require the minimum amount of user input that is necessary to construct the collector's config. And second fold is that if that config turns out to be bad, we are aware of it all the time. So we can notify the user rather than deploy a failing collector that has an invalid configuration. And the users don't need to know OpenTelemetry and its configuration besides some use cases. And also there is the fact that writing an OpenTelemetry collector configuration is really time consuming. I think everyone were here on the first presentation of today. The presenter showed us a OpenTelemetry collector configuration. If I saw the line numbers correctly, it was more than 200 lines long. So yeah, and the telemetry controller takes this burden off of your shoulders. And also the caveat slide I presented before, there was the buffering problem I mentioned before, and with Fluentbit. And you don't have that with OpenTelemetry, since the global upper buffer limit is no more, since you have distinct buffers for each pipeline. So the only obstacle is a not correctly chosen allocated disk space. And also, we kept in mind that the solution should be seamlessly integratable with the logging operator. Yeah, so let's see the telemetry controller. Another magic with the screen. I was fast this time. So for this, I have another script. Yeah. So for this script, we switched to another cluster that was created with this preset one. We are going to deploy the telemetry controller with its Helm chart. We're going to apply two manifests and use the same log generator to generate some traffic. So the telemetry controller has three or exactly four main custom resources you need to configure. Each of them is very simple. As I mentioned, we require minimum inputs. So the first one is the collector itself. It uses the same control namespace as we saw with the logging operator. So it has a namespace where the OpenTelemetry collector will be deployed. It has some tenant selectors, which searches on tenant labels. So you can decide how many collectors you want and which collector should watch over which tenant. And the tenants themselves have two main fields, log sources and subscriptions. So log sources is self-explanatory, which namespace should be treated as log source for the collector. And subscriptions should be So subscriptions are the one level of abstraction above tenants to root logs. And in our case, we have two subscriptions. This condition is an OpenTelemetry transformational language expression, which has to be evaluated to true, so the log can flow through. If we just put true here for the sake of simplicity, all logs will be transmitted. And also we need to select the outputs we would like to use. These are selected by name and namespace. And the outputs are somewhat similar to the outputs we had with the logging operator. In our case, it is going to be transmitted to a receiver collector, this one actually, which receives on OTLP on gRPC, and exporting it to the standard out for the sake of simplicity again. So if we switch clusters, we can see that we have this log generator, again, creating Nginx access logs. We have an OpenTelemetry collector that is collecting the logs of the file that I mentioned before. And you can see of the namespaces that I mentioned before. And you can see the path here that I mentioned on the first slide, that basically every log is just placed on the file. So it is sufficient to use a file consumer for that. And so ultimately, this collector handles the collection and the exporting of these logs. And if we check here, the logs are arriving. You can see that we have information about which tenant consumed transferred these logs, or more specifically, which subscription. So we have subscription 1 here, and we have a sample for subscription 2 here. So that's a really simple demo of the capabilities of the telemetry controller. And one thing I would like to show you is that I have a handy command for extracting the configuration that is placed on the that is used by the OpenTelemetry collector, and you can see that it is quite it's quite a configuration exactly. So yeah, it's pretty long, and it is totally created by the controller. So yeah, it's quite useful. Okay, so let's connect the dots. So not long ago, when we almost finished implementing the new telemetry controller solution, some of the users began reporting some buffering issues with the existing multi-tenancy feature in the logging operator with the Fluentbits that I pointed out in the caveats. Meanwhile, the OpenTelemetry-based solution were the elephant in the room we no longer wanted to ignore. So with our maturing telemetry controller, the timing was perfect that we finally add and evolve the logging operator with some OpenTelemetry-based capabilities. So we added best of both worlds, which was awesome, and the outcome was great, and the feedback was also awesome. So the only thing we needed to add was 2 feature flags to decide between the Fluentbit or the OpenTelemetry collector-based routing and the new few hundred lines of code in the logging operator's code base, so it can work together with the telemetry controller and orchestrate the work together. And what we avoided with this is we didn't break existing user workflows while introducing this somewhat of a complex and multi-purpose architecture. We avoided massive refactoring that would disrupt established patterns set by the previous user base. And also we avoided technical debt and user confusion from forcing fundamentally different architectures together. And so finally, for our final demo, let's check out the demo for this whole evolving. So with this final script, we switch back to the first cluster. We apply to manifests, and we recreate this Fluentd pod. Well, this is needed because we need to reload the configuration of the Fluentd aggregator, and there is a periodic config reloader sidecar within the pod, but this is faster, so we went with that. And also a log generator for a newly created customer B tenant. So with customer B, it's the completely the same as which we had with logging A. But within B, we can finally talk about this root config, and this is the 2 feature flags we've added. It's quite self-explanatory. And the another thing we needed was these tenant labels. So these tenant labels will be placed on tenants. So the collector, which is needed to be deployed by the infra team, should be chosen carefully for this tenant selector and work together with this tenant label, and they can mesh that together and it will work just fine. And what we did in the script is we created this B customer and patched the infra one, so it now uses the telemetry controller based routing. So this is somewhat of a scenario where you don't entirely trust a solution enough to try it fully. So customer A still uses the logging route. As you can see, infra is not here anymore, but we still have customer A here. So what this basically means is that we are now running OpenTelemetry collectors for infra and customer B, but not for customer A. And with that, we have this OpenTelemetry collector here that is collecting now for infra and customer B, but not for customer A. And we can see, we should be able to see all logs here from customer A to customer B, because it's just a matter of routing the logs based on Fluentbit or OpenTelemetry collectors, but the outcome is somewhat of the same. But the one thing that tells us that it switched to the OpenTelemetry based solution is that we should see a Fluent forward exporter here, which is an exporter used by the OpenTelemetry collector. So yeah, that's basically it. And one thing we can verify this with is that we have the customer B logs arriving at the same destination as customer A. And once we are satisfied with our solution, we can just clean everything up and get rid of the old solutions. So delete the Fluentbit agent, delete the logging route, and switch to OpenTelemetry, so we can leave the past behind. And right now everything is running on OpenTelemetry collector based approaches. We can see on the Fluent forward exporters here. Yeah, so that's basically it. Thank you for listening to me.